Projectile motion is a form of free fall. So it says a projectile is an object in free fall, but it's moving both horizontally and vertically. So in free fall, we've mostly looked at objects that are going upward, maybe they are going downward, or doing both. So that's mostly just vertical. Excuse me. But a projectile is one that also goes not only up and down, as you see here, but from side to side, so goes horizontally. So what's important to note here is that the acceleration due to gravity only works vertically. Gravity only pulls with an acceleration downward. Horizontally, gravity doesn't work that way, so there is no acceleration horizontally. Um, so there we have it. So we have two sets of equations. You'll recognize the ones on the right side. And if you remember, we've actually used the one on the left side as well. So the equation on the left side is very similar to the one on the right. We write this, but there's no acceleration horizontally, so this term is zero, and so therefore we just don't even write it. Let's write the horizontal variables. Position at time zero, position at a later time. Horizontal velocity. Excuse me. So, and t is for time. The vertical variables we know, um, but let's go ahead and do this. So this is the initial height, or in other words, the height at time zero, the height at a later time. This is the initial, or we should say the vertical velocity time zero, meters per second. Okay, well, and this is the velocity at a later time. Part of my handwriting. This is the acceleration due to gravity. That's what it is. And of course, t is time in seconds. Excuse me, sorry about that. All right. So with something like this, I kind of just want to jump into a problem. And we'll start by writing our list. We're going to need this for this problem. There we go. It says Otis the cat runs at 3 meters per second over the edge of a 1.1 meter tall table. So this table from here to here is 1.1 meters. The cat is running with a velocity of 3 meters per second. And I want you to imagine that the cat just runs straight off the table. Just kind of weird. The cat is not jumping up. The cat is not jumping down, but is running straight off. Sorry, let's fix that. 3 meters per second. So that's important to note. So they want to know how much time does it take for the cat to fall back onto the ground. So we want to figure out time. And B, how far from the base of the table does the cat land? So here is the base of the table. How far from the base of the table? So this is going to be a horizontal distance that we're looking at here. We're going to call this x naught, and we're going to call this x. And by the way, we're going to call this up here y naught, and we're going to call the distance down here, because it will eventually make it to the ground, this will be y. So we want to start by putting numbers where we know they go. It looks complicated, and I'll give it that. It does look complicated, but it turns out to be very simple once we get everything written down. Let's start with the heights. I think that's easy. The initial height is 1.1 meter. The final height would be the ground level, would be 0. A is negative 10 meters per second squared. And we actually know another one in this list, but let's move on to the horizontal list. X naught, we were used to putting 0 there. It's kind of like the starting horizontal position. We don't know x, but we do have a horizontal speed, a horizontal velocity, which if you look at the cat, it's very clear that the horizontal velocity is 3 meters per second. Cool. That's pretty much all we know. We'd actually know one more thing, but I usually like to show in class a video of this. Um, this cat is running horizontally, so when it starts to fall from the table, it's actually in free fall. And vertically, it had no speed to start off with because, like I said, it did not jump down, it ran straight off. And so vertically, it starts with 0 speed. So we're going to put 0 right here. I did an experiment in my classroom where I show a ball rolling off a table, and I show a ball being dropped from the same height. So it's kind of like this. A ball was rolling off a table this way, and at the same time, I dropped a ball that was right here. And when this ball fell from the edge, and when this ball fell, they do hit the ground at the same time. They started from 0 speed. It's as if it was being dropped. So this cat is as if it's being dropped. It's just true that it has a horizontal velocity to it. Cool. These problems are typical that we'll see. This type of problem, like a cat rolling off a table sort of problem. And question A says how much time? So we're looking at two lists here. We don't have enough numbers in this list to use that equation. We need to have 3 numbers if we're going to solve for one of the missing variables there. So it really falls on the vertical list, the vertical column. And we've done this many times. We have 4 variables. We just need to solve for time. And so we're looking for an equation with t that does not have vy. Oops, right here. An equation for t, but that does not have vy. So that's going to be the second equation. So I'm going to start it here. Y equals y naught plus, be very careful here, it's not v naught anymore, it's vy naught t plus 1/2 at squared. Y is 0. Y naught is 1.1 plus, this is a 0 value, 1/2. The negative 10 goes here, and t squared. Half times negative 10 is minus 5t squared, or I should say it's minus 5 times t squared. I change how I do this. I think today I'll just add 5t squared to both sides. We say 5t squared equals 1.1, like that. Divide by 5. T squared is equal to that. Let's get a calculator. We have 1.1 divided by 5. Get 0.22. Whoops. Which is not the answer. We got a square root. T is the square root of 0.22. According to my computer calculator, which I don't know how to use very well, it is 0.47 seconds, which seems very reasonable to me. And actually, I will say in our classroom, we have tables that are almost that tall, and that's about as much time as it takes to fall. So we have the time. Remember, leave it here. I will grade it there, but you can go ahead and put it here as well. I just won't grade it there. And the times are the same. The time it takes for the cat to travel this distance from, vertically, from that distance y naught to that distance y, to that height, I mean, is the same time it takes for the cat to go from x naught to x. So t is the same for both lists. And look, now we have 3 out of the 4 variables to solve for x. So I'll do my work right here. The only equation horizontally, which is on the previous page, is x equals x naught plus vxt. Vx is 3, is the speed of the cat, and the time was 0.47. So how far did the cat travel horizontally? It is something like 1.41, you can just say 1.4 meters is how far it traveled. So that's a typical problem for projectiles. The other type of problem we will see is actually shown on this previous page. We will not do that today. It's where an object is launched with a velocity at some angle, and it will sail through the air like so, or move through the air like so. So we'll see that for another lesson. Today we're just looking at this type of motion.